today we're going to be talking about special right triangles and how they apply to trigonometry. Back in geometry, you should have learned about two different types of special triangles. There is what we call the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. So let's start off with this guy, the 30, 60, 90. So let's pretend we're doing trig, because we are. And I want to draw a 30-degree angle. So a 30-degree angle is going to put me about here. Now, all of trig is based on the unit circle, so I'm actually going to draw a unit circle in here. All right. Now, I do a 30-degree angle on our unit circle. So what we know is this is 0, 90, 180, 270, and 360. Right? And on the unit circle, we know that this point right here is 1, 0. This point here is 0, 1. This point here is negative 1, 0. And this point here is 0, negative 1. So what I did was I drew a 30-degree angle on the unit circle. Now, since we're doing trig, once again, we're going to draw in our right triangle with the right angle sitting on the x-axis. Now, what do all the angles of a triangle have to add up to be? And I'm hoping you're remembering 180 degrees. So this is 30 degrees. That's 90 degrees. When you add them together, it makes 120. So that means this missing angle up in here has to be 60 degrees. So what I just did, you guys, is I made a 30, 60, 90 right triangle. Now, because this is the unit circle, the radius has to be the number 1. So right here, right this edge right here of the triangle, that's a radius, so I know that has to be a 1. Now, back when you were in geometry, you should have learned that in a 30, 60, 90 right triangle, the side across from 30 is always half of the hypotenuse. So, because we're on the unit circle, the hypotenuse is 1, so the side across from 30 here has to be half of that, which would be 1/2. The side across from 60 is always half of the hypotenuse multiplied by radical 3, which would make radical 3 over 2. So something really important I want you guys to keep track of here is if you see 30 degrees in trig, across from it will always be the 1/2 because you're on the unit circle. So when you see a 30 degrees go across from it, you're going to label that 1/2. And when you see a 60 degrees across from that, you're always going to label radical 3 over 2 because of the 30, 60, 90 proportions. Now we're going to do it again for the 45, 45, 90. So I'm going to draw another unit circle, right? So 0, 90, 180, 270, 360, right? This is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now I want to draw a 45-degree angle. So 45 is right in the middle here. Okay, so now because we're doing trig, I'm going to make a right triangle. Now if this is 45 and this is 90, they add up to be 135, which means this side is 45 as well. So that's why it's a 45, 45, 90. Now, just like here, because we're on the unit circle, it means the hypotenuse has to be the number 1. Now in a 45, 45, 90, you should have learned in geometry that across from 45 is going to be half the hypotenuse multiplied by radical 2. So it's radical 2 over 2. And this would actually be an isosceles triangle because both of these are 45. So since that's 45, that means here would also be radical 2 over 2. So the other important takeaway from this, when you do trig, if you see 45 degrees, when we draw our triangles, you're going to label across from that radical 2 over 2. Okay, so why is that important? So this is really important to write down. So why is that important? Well, we're going to pull together all the things we've been doing this year, or at least in trig, to use this. Now I'm going to say evaluate. And I'm going to say evaluate cosine 150 degrees. All right, now watch this. Cosine 150. Now we always assume we're on the unit circle, so I'm not going to draw it, but assume it. This is 0, 90, 180. So this is like what we've been doing the last few days. 150 puts me in this quadrant. So from here to here, that's 150. Now, we're doing trig. So we're going to draw in our triangle. So that's my right angle. What would this reference angle be? Right, that's 180, that's 150. So I'm going to do 180 minus 150, and I get 30 degrees. So my reference angle is 30. Well, guys, anytime this is 30 and this is 90, guess what he has to be? 60. So as soon as you see 30 and 60, we can start labeling the sides now. Because look here, 30 degrees across from it should be a half. Well, here's 30 degrees. Across from it, I'm going to label 1/2. 60 degrees across from it, I'm going to label radical 3/2. Now watch how I do this. Cosine 50. Cosine 150 we created now from this triangle. Now on the unit circle, cosine is always the x and sine is always the y. So what number is sitting on the x-axis? That would be radical 3/2. And in that quadrant, that's the S quadrant, the sine quadrant. Since we're doing cosine, the answer is going to be negative. So that's the answer there. So let's do another one of those. Right, we're still evaluating. Okay. This time I'm going to do sine 240 degrees. Okay. So 240. So 0, 90, 180. Down here is 270. So 240 is going to pull me about here. Okay. Draw my triangle. Okay. How far past 180 did we go? What's my reference angle? Well, if I do 240 minus 180, I get 60 degrees. So that means this is going to be 60. Hey, if that's 60 and that's 90, that means this guy's got to be 30. Across from 30, we're always going to write 1/2. And across from 60, I'm going to write radical 3/2. Okay, sine, right? And a minute ago, I showed you here, sine is always the y value. Well, the y-axis is vertical, so the y value would be this guy right here. So that means sine of 240 degrees would be radical 3/2. And then we do A, S, T, C. That's the T quadrant. So that means the answer has to be negative. All right. 3. Let's do tan. Let's do tan at 315 degrees. Okay. 0, 90, 180, 270, 360. So 315 is going to be between these two. So from here to here is 315. Now, since we're on this side of the graph, right, we're going to draw our triangle. Since we're on this side, we're going to subtract from 360 instead of 180. So I'm going to do 360 minus 315. That makes 45 degrees. So that means my reference angle is 45. Well, if that's 45, then this guy's got to be 45. Now we're going to label the sides. Across from 45 is always going to be radical 2/2. Radical 2/2. Now, tangent. Two different ways of doing tangent of this guy. Tangent is either opposite over adjacent, so or y over x. It means exactly the same thing. See, opposite, it's the up and down, that's the y. So I'm going to do radical 2 over 2 over, and the x is this guy. Well, guys, when the numerator and the denominator are the same, they cancel each other out, and this becomes the number 1. So all we have to do now is check for ASTC. ASTC. This is the C quadrant. So what does that mean tangent has to be? That has to be -1. All right, so I'm going to have you guys try one more on your own, and then we're going to do something different. 4. All right, let's do cosine 240 degrees. Give that one a try. See if you can come up with the answer. Okay. 240, 0, 90, 180, that's 270. So once again, we did this one before. 240 pulls me to here. Draw your right triangle in. So this is 180. So since we're on the 180 side, I'm going to do 240 minus 180. That makes 60. That's 60, which means this guy is 30. Okay. 30, across from it is a half. Across from 60 is radical 3 over 2. Now, cosine. Cosine is always equal to the x value. What number is sitting on the x-axis? Oh, 1/2 is. So the answer to this question is going to be 1/2, but we have to do ASTC. Notice the triangle is drawn in the T quadrant, which means this answer is -1/2. Okay, now, I had posted up and I had suggested that you guys print out the worksheets that said special right triangles on there, right? So this is much easier to do if you have this printed out. If you don't have it printed out, if you at least drew the diagrams, it makes it a little easier to do together. So let's take a look at number 1. Okay, now, if you haven't done this, you should stop the video, print these out, or copy them down. But let's take a look at number 1. In the accompanying diagram, the center of circle O is at the origin. OB is the radius, which is 1, and this angle is 30. What are the coordinates of B? So I got to figure out what that location is. Well, guys, we're doing trig. So what you're going to do is draw in your triangle. So what I'm going to do is actually draw this bigger so you can see better. So here's the unit circle. And what they have here is this is 1 and this is 30. So what you should be doing is creating your right triangle. Now, that's 30. What does that make that corner? Well, then you're thinking 60. So here's what it be. All right. What do we always label across from 30? That's a half. It's across from 60, radical 3 over 2. Now, we have enough information to find B. We need a point, right? A point is x and y. Well, this is over, right here, is radical 3 over 2. And we go up 1/2. And that is the coordinates of B. So that would be choice C. All right, so get number 2 now. In the accompanying diagram of circle O, point O is the origin. YO is 1. That's 1. JO is 1. So that means we're on the unit circle. And toy is the diameter. If the coordinates of this point J are radical 2 over 2, radical 2 over 2, how many degrees is the angle? All right, so again, I'm going to draw it bigger. Okay. So this is O, Y. And they said this was 1. Okay. And they said this is J. And they said this is 1. And they said we have radical 2 over 2, radical 2 over 2. So what I'm going to do is draw in my right triangle. Okay. Well, Guys, radical 2 over 2. See how that's the x? So it means on the x-axis, this little part right here is going to be radical 2 over 2. This part right here is going to be radical 2 over 2. What angle goes with radical 2 over 2? And I'm hoping you're thinking 45 degrees is. So the answer to this question is 45 degrees. Okay, so let's try it again. All right, let's look at this picture. In the accompanying diagram of the unit circle, the ordered pair xy represents a point where the terminal side of theta intersects the unit circle. If theta is 120, what is x? All right, so once again, I'm going to draw this bigger. Okay, so they have this here labeled xy. And from here to here, they're saying that angle is 120. So guess what we're going to draw? A triangle. That's 120. What does that make our reference angle? That makes that guy 60. So what does that make that angle up there? 30 degrees. All right. So what do we always label the side across from 30? It would be a half. Across from 60 is radical 3 over 2. Now, they want us to find the value of x. Well, check this out, guys. We're going back how much, right? On the x-axis, this is the positive side of the x-axis. This is the negative side of the x-axis. So that would make it negative a half. Choice C. All right. Now, number 4. In the accompanying diagram of the unit circle, the ordered pair xy represents a point. So this is very similar to this question. I'm going to draw it bigger. Right, so we have right here is xy. Okay. And then they have this angle here. Okay, and they're saying that's theta. And theta is equal to negative pi over 3. Now to do this, we have to convert this into degrees so we know what's going on. So negative pi over 3, to convert it, you're going to multiply it by 180 over pi. Pi's cancel. So I get negative 180 over 3. So that makes negative 60. So that means this angle is 60 degrees. So that means we're going to draw a triangle. Well, if that angle's 60, what does that make this angle? 30, right? Across from 30 is a half, and across from 60 is radical 3 over 2. All right, now in this question, they want us to find the y. The y is always the up and down fraction, which would be this guy. Now, is this on the positive side or the negative side of the y-axis? Right? It's down. So it's going to be negative radical 3 over 2. That would be A. Okay. All right, what I'd like you guys to do is try number 5 without me. So you should pause the video, give number 5 a try, and let's see if you can do it. Okay, so hopefully you pause me and you try number 5. All right, so in number 5, again, I'm going to draw bigger. Okay, and there's an angle here. Maybe this is x, y. And they're saying from here to here is theta. And they're saying theta right here. Theta is 150 degrees. Okay, so if I draw my triangle, that's 150. What's the missing angle going to be? I'm hoping you're thinking it's 30, which makes up here 60, right? Across from 30 is a half. Across from 60 is radical 3 over 2. We want to know what's on the x-axis. Now, radical 3 over 2 is on the x-axis, but is that on the positive side or the negative side? It's on the negative side. So we're going to pick choice B. All right, let's look at number 6. I'll do this one with you. if theta is an angle in standard position and it passes through that point on the unit circle. So what I'm going to do is graph it. I don't know if you guys have noticed, it's a lot of drawing involved. So I'm going to draw a unit circle, because it says unit circle, and a point 1/2 radical 3/2. That means I'm going over 1/2 of radical 3/2. So if they give you a point, it means go over 1/2 up radical 3/2. So we're there. And then you guys are going to make a triangle out of it. So this one's us going backwards, right? What angle is always across from 1/2? So see the 1/2 here? That means across from it, this corner has to be 30. And radical 3/2 across from that has to be 60. So the question is, anytime they ask for theta, they want to know what the reference angle is, what the corner is right here. And that's 60 degrees, which is choice B. All right. So let's take a look at this one. In the accompanying diagram, point P is 0.6 and negative 0.8. What is the value of theta to the nearest degree? Now this one's a little tricky. I don't have this one on your homework, but I wanted you to see it. So we have a unit circle, right? And P is here. Now see how it's 0.6? That's your X and that's your Y. So that means I'm going over 0.6 down negative 0.8. And they want us to find the angle. Now, let's look at what they gave us. 0.6 and 0.8 aren't either 1/2 radical 3/2. It's special. So we have to do this a little different. Where are these two located? This guy is opposite the theta, and this guy is adjacent of the theta. Which trig function has opposite and adjacent? And I'm hoping you're thinking tangent is. So I'm going to plug in here. Opposite would be, actually I'm not going to put the negative. I always like to keep it positive. So don't put the negative. It's going to be 0.8 over 0.6. And anytime you want to find an angle, now let me make sure you guys are setting the calculators up right. When we're doing trigonometry, you're going to hit mode and make sure when you scroll down the degree is highlighted. Now, I want to find an angle. So if you notice it says sine, cosine, tangent, but above it in blue it says tan to the negative 1. That means we want an angle. So I'm going to do tan to the negative 1. And then I'm going to do the fraction. I'm going to put 0.8 over 0.6. And that's 53 degrees. So that makes this corner right here 53 degrees. Okay. However, that's actually not the answer. They always want to know what the turn is going to be from the beginning. That's always in trig. It's always the beginning from this direction. So there's two answers you could give. You could say it's down 52 degrees, right? Or you could do 360 minus 53 and give 307 degrees. So either one of those is correct. You will not have one of these on your homework to make this a little tricky. Now, I just want to show you this one. You won't have one like this in your homework either, but it's important to check it out. In the accompanying diagram, this is a unit circle with these weird triangles drawn on it. All right, and it says OB equals 1. So I know, where's my red pen? I know this little part is 1. Which line segment is equal to cosine? All right, now here's the deal. If you know OB is 1, we know it's a unit circle. And guys, all we care about is the triangle inside the unit circle. All of the rest of this is like garbage. So let's look at this. Cosine is always equal to x. So what is the letters on the x-axis of this little triangle? It's OA. So that would be B. Okay. And finally, right, I'm going to stop. See if you guys can do this. Pause me. See if you can do this number 9. Your homework is going to be kind of like these, the ones that we practiced at the beginning of this worksheet. So see if you can pause me and do number 9. All right, so hopefully you pause me. Okay. It says, in the diagram below is the unit circle. The ordered pair negative radical 2 negative represents. So what I'm going to do is draw my triangle here, like that. And that means I go back radical 2 over 2 and down radical 2 over 2. What angle always goes with radical 2 over 2? I hope you guys are thinking 45 degrees. So that means your reference angle, the guy in the corner right there, is 45. They want to know what theta is. Theta is always the turn from here to that line. So how far would that be to travel? Well, this is 0, this is 90, this is 180, right? So that means we went 45 degrees past 180. So if I do 180 plus 45, that puts me at 225 degrees. So that would be choice C. Now, another way of kind of cheating at this answer, look what quadrant the picture's in. 45 degrees. What quadrant would 45 degrees be in? Right here. There's nothing there. So that's not the right answer, right? B, 135, means we would have been here. There's no triangle there. So it would have been down to a 50-50 guess. And the fact that it's radical 2 over 2, that's why it's 45 degrees. And there you go. So these are what you guys are going to practice tonight. We'll talk about it later on.